First example, find this integral from 1 to 3. This is a definite integral because it has those numbers there, 1 and 3. X squared plus 2 dx. Now remember, we could think of it this way. If we want it to. Okay? That may take some extra calculation. It may be the same amount of calculation, but just another way of thinking of it if you wish to think of it that way and you find that easier. Okay, I'm going to keep them together. So this is, we're taking the integral of this, so we're increasing that exponent by 1 and dividing by that number, and that 2 becomes a 2x, and we have our plus c. I'm going to put that plus c in there for now. You're going to end up seeing that we actually don't need that, and we'll see why. We actually don't need the constant of integration with definite integrals, and we'll see why in a moment. And maybe you can figure it out yourself, because we'll come back to that in a second. So we need to use this notation. We've got 1 and 3 here. Okay, so this means that I'm going to now substitute in 1 and 3 for x. But first I want to simplify. So x cubed over 3 plus 2x plus c, 1, 3. Now remember, it has to be, we have to substitute in the 3 and then subtract that from substituting in the 1. Okay, so in other words, we're thinking about this. F of 3 subtract f of 1. And that looks like this. 3 cubed over 3 plus 2 times 3 plus c, subtract 1 cubed over 3 plus 2 times 1 plus c. So this is 9 plus 6 plus c, subtract 1/3 plus 2 plus c. 15 plus c minus 2 and 1/3 plus c. So 15 plus c, subtract 2 and 1/3, subtract c. The c's cancel out. So we have 15 subtract 2 and 1/3, which is 13 and 2/3, or 39, 40, 41 over 3. And looking back, I think I did that wrong. 15 subtract 2 is 13. Subtract another 1/3 is 12 and 2/3. So 36, 7, 38 over 3 would be and also an acceptable answer. So actually we didn't need the constant of integration with definite integrals because they result in c subtract c, which equals 0. Okay, very important to understand that. Okay, next example 21. Evaluate this integral sine x dx from 0 to pi over 3. All right, so take the integral of that. The integral of sine x is, I always forget these ones. Let me see. So if I'm differentiating, sine x goes to cos x, and cos x goes to negative sine x. So if I'm going back the other way, negative sine x becomes cos x. This is a positive sign, so it ends up in a negative cos. Okay, so negative cos x. We don't need the constant of integration because we're dealing with a definite integral, but it's from 0 to pi over 3. So we have to do this. Negative cos of pi over 3, subtract negative cos of 0. So pi over 3 is up here. 1, 2, 3, so 1/2. and 0 is 1. All right, so negative 1/2. Subtract negative 1, which is negative 1/2 plus 1, which is 1/2. Notice we end up with a numerical answer. Second one, the integral of 2x plus 3 over x dx from 1 to 4. Okay, so the first part is our regular rule. The second part, we need to use lns. We're going to have 2x, increase that power by 2 and also divide by 2, plus 3 ln of x, absolute value of x. Now you'll notice here we're actually going to be taking the absolute value, but they're both positive numbers, 1 and 4, so it won't look like we're doing much. Okay, so that's x squared plus 3 ln absolute value of x. So 4 squared plus 3 ln 4, subtract 1 squared plus 3 ln 1. Okay, when we're dealing with logs, we always need to make sure, is there a better way of writing it, or can it be simplified to some number? So let's think about that. Ln 4. Ln 4 is the same as ln 2 squared, which could be written as 2 ln 2 by our third law of logs. And ln 1 is equal to log, if we use that little trick, log base e of e to the 0. Okay, so 1 is e to the 0, so therefore that's just equal to 0. Okay, that will simplify things considerably. So we've got 16 plus 3 times 2 ln 2, subtract 1 plus 0. 16 plus 6 ln 2, subtract 1, 15 plus 6 ln 2. Perfect. Okay, last example, looking at our calculator. Okay, so we need to evaluate this, x e to the power of x dx, to an accuracy of 4 significant digits. Let's see what we can do with our calculator here. So we have a little button here that will show us that we can do integrals, just like we could do derivatives. And where do we have it? Here we have it, this little button right here. It's a good button. There we go, press it. So let's just fill in our information. We need a 2 here. We need a 5 up here. We need an x. An x. X. And then e to the power of x. E to the power of x. And then scroll over here, dx. Enter. It actually gives us that answer. So 586.264. We need it to 4 significant digits, so 586.3. Your homework questions from 18H, written on the homework document. Please take a look at that and have fun.